Oh, hello. So, a few months ago. Wait, what? It's been that long? Wow, doesn't time fly? Anyway, I left off that video saying I had other plans, and now, a year later, I can share with you the making of the Discord kettle. I did most of the programming last year, and I've forgotten where I learnt the code from, so apologies for those I can't credit, but there's plenty of resources out there, I'm sure. This video is more of a guide than a tutorial, so I'll not be explaining the code line by line. I should really get a GitHub, shouldn't I? Only recently I've found out that there is an Arduino IDE version 2 with IntelliSense. Ooh. So if you are still using V1, then check out V2. Picture the scene. You are a million miles from your kitchen and all you want to do is click that little trigger to tell the kettle to start boiling, and then you bugger off for a few minutes while you wait. The first problem to fix is the initial remote toggle. Lucky for us, a servo motor is a good substitute, cheap and easy. Right, so here's a servo motor. Now, how are we going to control it? Well, with an Arduino, I hear you cry. Well, yes. However, if your computer was close enough to the kettle to have an Arduino connected, then we wouldn't have this issue to start with, would we? It is possible to add things like Bluetooth or other wireless communication to an Arduino so we can remotely control it within our home network, or we could use a polymerization card and fuse the two into one device to create a board known as an ESP8266. We will start off by getting the servo motor to actuate. The ESP is a 3V device, so I will power everything with this 3V power supply. I will now test the servo motor. I will now award the servo motor with its NVQ in kettle operating. Next, I don't want to be in the same room as the servo motor. I just can't even. So I will send it instructions wirelessly. To do this, we need to write some code to allow it to listen to messages over the Wi-Fi, since this is the Wi-Fi version of the ESP8266. To be able to send TCP messages, we will need to write another program to make a connection and send the instructions. But I will program straight into the Discord bot app, as I'll need to do it here eventually. The last tutorial I made shows how to do this in full. If you do not wish to use a Discord bot, the same code could be usable in another application anyway. But we could always use Putty as a pre-made tool to test our application. First we need the bot to read the chat messages using the message created event, and when this happens we can check that the message was sent in a certain server or by a certain person. Back in Discord we can check by typing hello and we get our message hello in the console. We can of course check what message was sent and return a pleasant response in the channel. Domo arigato, Mr. Roboto. I'm going to use the string K1 to tell the Arduino when to run the servo motor. I'm then going to change the Arduino code to look for this K1 value so that when we receive this, then we can run the servo motor. And we will respond with R1, which we will set up later. Let's watch it all working in console messages first. Typing the command into Discord, the bot recognizes it by displaying the custom console message. It then makes a connection with the Arduino. The bot then responds with a nice message. The Arduino then tells us it's received the command K1, which is needed to run the servo command. And then, after some time, the Discord bot receives R1 from the Arduino. Finally, when everything is done, the Discord bot disconnects from the Arduino. Now, seeing it in real time with this low quality video, the servo actually runs. And there she blows. The application can send instructions to the controller over TCP messaging. We're done here, but are you an overachiever? Then stay a while. Scooch closer. We are going to do what can only be described as a pro gamer move. We could just guess when the kettle is done, or the kettle itself could tell us, so we're going to code to listen when the kettle is boiled. We are going to need a thermal sensing device, or a thermometer if you must. I did think about piercing my kettle, but oh no, if that didn't work I would be without a kettle, and, well, I'm not sure how I would live without one. I mean, how will I eat my wider range of meals, such as pot noodle, Moving on. I bought a cheap kettle to violate instead, but then realised I could just measure the temperature from the outside.
Stupid!
Back in Arduino, we need to download some libraries for the thermometer. In the library manager, we need the Dallas temp and one wire libraries to connect to the sensor. We need to use the SPI clock pin on the board to connect one wire devices, which is pin 14 on this ESP8266. Looking at some circuits online, we're going to need a 10 kilo ohm resistor between the data pin and the power pin. Using the library, we'll write a small function to print the temperature reading and then just loop this function, ignoring the rest of the code. It's reading about 30 degrees currently because we have been blessed with summertime in the UK and it's hotter than Satan's. Assuming everything is working correctly, we can see what the kettle reports when it's near a boil. There is some thermal lag between the water and the thermometer as it's only reading about 40 degrees. We can just set our boil temperature to this as the kettle will boil to temperature anyway. The code will be changed that when the servo motor has run, we can loop and read the temperature. When it rises to our threshold, we can return a message to say that we are at temperature. With this response from the Arduino, we will need to make a change to the bot program to know what this response means. We can change the switch statement so that when we receive R2 from the Arduino, we know it is boiled and we can notify the user. When I type the command into a text channel, we see the familiar hand shaking in the consoles. The Arduino is still programmed to write the temperature to its console, so I will warm up the probe with my fingers to test that the final response works. Happy days! And we get the client disconnected too, so the sequence is working as intended. But of course, there are that small group of people in every Discord server, the undesirables, the lesser beings, the spammers. We do not want to just turn on the kettle whenever we please. There has to be sufficient water in place to prevent a kettle meltdown. There are a few ways of sensing water level, but I'm going to use a weighing scale and just weigh the water content in the kettle. We are going to add another method which will deal with the weighing. We need the HX711 library to set up a set of digital weighing scales. I'd love to tell you which one of them I downloaded from the library manager, but I didn't use any of them. Sorry, what can you do? I will write a small function to read the scale values and print to the console, like we did with the thermometer. We need a reference value for the setup to make sure the scales read properly. I needed a calibrated load, so I listened to 10cc for inspiration and got to work. I changed around this value until the scale read the load I had. Okay, this works, so now we need to change the program to return an error if there is not enough water, otherwise we will just be waiting forever and eventually die. What's the saying? A watch pot never boils? I'm going to add a simple else statement to the check for a weigh value. If it is less, then I will send E1 to the bot to identify an error. In the bot program, we will add to our switch statement this E1 value, which will print out an error message. Great, this works. I printed a support for the scale and the servo motor. I will then weigh a single cup of water to use as the minimum weight. With this weight found, everything is ready to go. But I do not encourage you to put unknown objects and materials inside a kettle, as you do not know the chemical makeup or toxicity that is going into the clean drinking water. Additionally, there is every chance that the servo motor will get stuck down, keeping the heater elements active, boiling off the water and burning and melting down. Congratulations, you have just witnessed what happens to nuclear reactors in meltdown. So, here we go. Gee, would you look at that, my mug is empty. Better get on that right away. Okay, let's go. Ah, well, I guess I will leave this to steep. Oh, I forgot about you. Well, that's a problem for another day.